So since complex conjugate roots occur in pair, they will get subtracted. When you subtract them, they will get eliminated. So that is not going to be an issue here. So this point is very, very important, because from this point only the root locus starts branching outwards. If the real axis of a branch lies between a pair of poles, the root locus breaks between the poles. If it is between zeros, then it will be the entry point. So if you have a pair of poles and the branch is between them, now it will start breaking away from the real axis. But if you find that the branch is between the zeros, now it will be entering through that point and it will be ending in the zero. Root locus always starts at poles and ends at zeros, right? So whenever you have a branch between the poles, it will go out from that branch. Whenever you have a branch between zeros, it will come and merge with the zeros. That is what is given in rule number 6. So if a real axis lies between two poles, then the poles might eventually head off to zero. That is what we said. It definitely has to travel from poles to zero. So definitely when you have a branch between the poles, it has to go away from the poles. And if the real axis lies between two zeros, then eventually it will terminate in zeros. So breakaway point you have to find using the formula, what is mentioned there. The next for you are going to find what is the angle made by the root locus for every pole and zero. The angle is given by theta p equal to 180 minus summation of poles plus zeros. Theta z equal to 180 plus summation of poles minus summation of zeros. So this will find what is the angle made by each pole or zero. This will find the angle made by each pole or zero with the corresponding root locus path. You can see here I have a zero here, I have a pole here, I have a pole here. So join all the points to some test point, and from that you can find what is the angle made by the zero and the pole. So the angle, you can use trigonometric formulas to find out the angle. So essentially you can see when it is close to pole, the phase angle contribution by the other poles also you have to consider. When it is close to zero, you have to consider the contribution by all the zeros also. If a particular value of S is known to lie inside the roots of what is the value of K, you will find for that particular value of S. So K is equal to 1 by G of S. So that value of K will be K is equal to 1 by modulus of G of S. So it is just a simple magnitude condition what we are going to consider. So the 8 rules, whatever we have studied, so they can be only found from the magnitude and phase conditions. And you cannot say that it is sufficient to draw the root locus using the 8 rules. No, I cannot say it is completely enough to draw the root locus using the 8 rules, but some other additional rules also might be required for dealing with complex problems. So whatever rules we have developed are only for negative feedback system. Okay, so same can be applied for positive feedback, provided we have to modify the rules for the phase angle condition. For k less than 0, the angle will be n into 360. So wherever you have odd multiples of 180, you should replace it with integer multiples of 360. So because for positive feedback, the parameters are going to change, the conditions are going to change. So for negative feedback, it is odd multiples of 180, and for positive feedback, it is integer multiples of